great to get this season kicked off with combustion controls. I titled this presentation, How to Be the I Can Fix It Today Contractor. Sometimes you get out on the job site, you have a control, a part that you need to be replaced, and you don't have that exact part on the truck. Can you fix it while you're still there? And there's a lot of universal options that are out there today that really make it so that you do have the ability to change the product, put the new part in while you're there, save yourself that trip to the supply house. So we're going to go through understanding universal combustion controls, some slides showing what we have from Emerson White Rogers for product offering, but also giving you some pointers along the way and some tips and a little bit of basic understanding of how different components work as well. Our game plan for this evening is why use universal, understanding and identifying the correct universal control, and then universal searching tips. You have a universal part that you'd like to use, or you have a part that you need to see, hey, is there something out there in the universal realm? I'll give you the tips on a couple different ways. One of them with your phone right out there in the field that you can check your part against what's available and know that you have an exact replacement with you at the time. Part one, why use universal? Universal is kind of a mindset of understanding how universal is going to work for you. There's obstacles that you have, why you want to consider it, as well as understanding the benefits of those options of using universal. Universal obstacles is probably the biggest one that I would see is we gravitate away from the unknown, something that's we don't know anything about, we're not comfortable with, we're not familiar with. We lack that familiarity, we think it's complicated, and we had never been trained on it. That's where I'm here tonight to hopefully give you some of that training, give you some of that understanding, because the more we understand something, the easier it becomes to embrace. We can look at a woods as a dark, scary place, but when there's enough light shed on it, it's a nice path for a walk. Understanding brings ease of use. Understanding how something works makes it so that, hey, this is something we can do. Why do we want to consider universal controls? Well, when a system fails, do you research OEM only? And if your company has to pay the overnight freight to get that OEM part in very soon, that can take your profit from your sale out the window right away. And the other thing is the cost of aftermarket parts. They have the potential to save the contractor, and you can pass that savings on to the homeowner, money from the fact that part is made with the intention of being a universal replacement part. White Rogers has a name for high quality aftermarket components, controls, and some of those components, controls are universal furnace controls, IFCs, the hot rod flame igniter, as well as gas valves. 77% of single stage furnaces made in the last 15 years can be replaced by one of 5 of White Rogers universal control boards. 86% of furnaces with 120 volt ignition systems can be replaced with one of 2 of our hot rod igniters. And 80% of furnaces made in the last 15 years can be replaced with one of 6 gas valves in the 36J series. And I'm also excited tonight to share with you a 36G gas valve that is covering the same features, but is a more compact, easier to fit in application product. So stocking universal projects can eliminate those trips to the supplier, that time of the technician going. And homeowners typically don't like to wait for their repairs. If their house is cold, they don't want to hear, I got to have that part overnighted tomorrow, or I'm not able to get that. Having the mindset of, let me see if this universal part will work, will save you a trip and save the homeowner a lot of anxiety and make a lifetime customer potentially. So let's go to part 2, understanding and identifying the correct control. Universal control features, and the control overview that we want to go through now is igniters, flame sensors, non-integrated modules, integrated furnace controls, and gas valves. So this I divided up into 2 slides. The first slide covers the igniters, a universal flame sensor. That's a new product that we're launching this fall, and I'm excited to share with you tonight. Non-integrated modules, as well as the IFC or integrated furnace controls. Igniters, we have 2 that are universal, that cover the whole spectrum of things. The flame sensor, one universal flame sensor that can be cut and or bent to fit the existing flame sensor size and bend. Non-integrated modules, which are both direct spark, proven pilot, and hot surface ignition, as well as a fan timer control that's a universal product as well. And then with the integrated furnace controls, we have both the 50M56U, which is the single stage PSC, as well as the 50X57, which is the single stage ECMX or X13 universal control, as well as the 21M and the 21V being a multi-stage PSC and then also a multi-stage ECMX. The second slide here on all of our overview is gas valves, and as I mentioned a little bit ago, we have the 36G32 and 36G33 are 2 brand new valves that we're launching here this heating season. They are single stage, one's fast opening, the other slow opening, and they are a smaller footprint that can fit in a lot more applications for you. We'll go over all of these gas valves as we go through that section, explaining them a little bit further in detail. So the first section that we had was the igniters. And let's talk about ignition systems for a little bit. There's 3 types of ignition systems that are primarily used right now. The direct spark ignition, the silicon carbide, and the silicon nitride, which is the most popular on the market today. The direct spark is a product that the spark probe itself rarely wears out. The part that will fail or break is the actual control that's sending the spark to the metal there that's creating that spark. So it's the most expensive to do a repair on because typically you're repairing the board, not the igniter itself. It is also a very fast ignition because you don't have to wait for the igniter to warm up or to heat up to ignite. It instantly sparks and you can have an instant ignition. Silicon carbide is a product that was the first round of silicone products that came out. They're known to fail sooner in some environments. The probe itself, the igniter, is brittle. It's easy to break, and it can be broke while it's installed, or it can be broke at any time when a repair is being done and it would happen to get hit or knocked. The probe itself is the part that fails, making it a less expensive option for repair versus the spark ignition. But our third option is really our best option because the nitride, silicon nitride, It's more of a premium probe. It's durable. It's longer lasting than silicon carbide. It's not sensitive to oils, and so there's no fear. And there's two rules of thoughts out there. One is that touching silicon carbide with the oils will break that down faster. There's others that would say that makes no difference. Whichever, and I'm not going to give you a conclusive answer that it's one way or the other tonight, other than the fact that we do know that silicon carbide igniters tend to fail faster than the nitride. The nitride is more durable, and it is the longest lasting, and currently today it's the most preferred by furnace manufacturers in new manufacturing. So in selecting an igniter, you need to understand what the voltage is, your length, and what type of material you have in an igniter. The traditional silicon carbide, which I show here on the slides, is a product that can be replaced with a standard hot rod. And then if there's a carborundum style silicon carbide style, the hot rod EX. The difference between these two: this is a longer rod, this is more of a compact rod. This is round, this is a shorter flat piece within that as well. Also within the different silicon carbide, there's multiple styles of bases that are existing within the silicon carbide options. All of those silicon carbide options can be replaced with a hot rod, with a silicon nitride. You can take out a carbide, put in a nitride. The main thing that you're looking for is that it's going to be 120 volts ignition system from the control itself. And then you're going to match up whether you have something that's a standard length or a compact length. And whichever length you have is what you're looking to replace. You want that igniter to fall in the same spot that the old silicon carbide igniter was. And a little bit of a tip along the line of doing this is, when you do this upgrade, you want to make sure that you ignite the furnace multiple times. And the reason for that is, if your new igniter happens to be off or in a little different spot, when the gas comes out and it doesn't catch that igniter instantly, you can have some delayed ignition. And so to prevent you from a return trip, going back and doing an adjustment on the location of that, fire the furnace multiple times, be there at the furnace, make sure that when it ignites, that it's igniting instantly and that you don't have any sign of any delayed ignition. Save you a trip down the road from that. Both of the White Rogers igniters are in the universal line are 120 volts. So anytime you have an 80 volt igniter, you would need to replace it with an 80 volt igniter. The nitride is more robust. It's stronger than the silicon carbide, which I've already shared. The silicon carbide can break really easy. You want to make sure that it's a solid piece. If you're still buying silicon carbide, you need to check that when you're making the purchase of it. Open it up, verify that it's intact. Or buy a White Rogers Hot Rod Universal that you can see through the packaging and you can tell it's intact. You wouldn't even have to worry about that because of its strength, though. And we're comfortable enough with this silicon nitride igniter that we offer a 5-year warranty with it. So it's a product that we're comfortable with saying it's definitely going to last. It's something that you can replace. You can upgrade any silicon carbide igniter that's 120 volt with this, and it's going to fulfill the same response. Here again, some of the nitride benefits: its durability, it's tougher, it's also more non-porous. You can visibly see that the surface of the igniter is smoother, and it has additional strength. It will outlast with longevity 2 to 5 times that silicon carbide igniter. And then finally, time saving. Diagnosing a defective nitride igniter is faster than diagnosing whether a spark igniter has failed if that spark ignition isn't arcing and covering that gap. It's sometimes hard to determine, is it somewhere in the wiring, is there something else going on, and you can simply know that your igniter isn't glowing, it's not working. It's a lot easier to pull out and put back in rather than pulling all the wires off of a control box of a spark ignition control and rewiring it.
Real quick, Jim. We got a question in from Todd. So Todd asks, does your igniter warm-up timing matter when picking a replacement?
That's a good question, Todd. The warm-up timing does matter, and there are some igniters out there that were called micro or mini igniters, and they were small igniters that had somewhere around a 7-second warm-up time. They were known to go out very fast or to fail fairly fast, and that 7-second window was all that was given to them because of the type of material in their design. That design does not cross over to the hot rod, which would have a larger size, a larger base, and typically on these you can have the 17-second normal warm-up time all the way up to the 34-second, which some controls have, and the silicon nitride can handle being on for that whole amount of time, and it's not going to affect its length of life or its operations. So the answer to the question would be it doesn't matter on the warm-up time. All of your controls are going to be 17 seconds or greater that this would fit into and work with. The final slide here that I have on the universal hot rod is just simply a little bit of an overview of what that hot rod is comprised of, both the 21D64-2 and -44. And again, the hot rod itself replaces over 170 spiral igniters. The hot rod EX would cover 260 flat igniters. The wire leads, they're universal leads that are between 14.5 for the hot rod and 15.5 for the hot rod EX. And they would also have wire nuts. How you connect that to the furnace there's 2 options. As a former contractor, I would typically cut the plug-in off of the old igniter and wire nut that old plug-in onto this igniter and leave the furnace wiring harness intact. You can cut the plug off of the wiring harness and wire nut directly to that. It makes no difference either way. If you cut it off, if you cut that plug off of the old igniter, in the future, if there was any work or repair done needing to pull the burner or the igniter out of the furnace, you have that plug to unplug rather than deal with trying to take off wire nuts and put them back on, and anything that would be involved if sometimes the wire nut doesn't come off very easy, sometimes the wires come out with the wire nut. If you adapt and wire nut to the end of the plug, then you can plug that back into the existing furnace plug and you don't have to worry about that. The hot rod also comes in a 5-pack, 21D64-5 5 PK. And both of these do have the 5-year warranty. The Hot Rod series, it gives you a lot of options beyond silicon carbide. And what I want to emphasize is the fact that this is silicon nitride. It can replace both 120 volt silicon nitride igniters and 120 volt silicon carbide igniters. Either one. You don't have to have an old nitride to use this to replace it. You can replace that old brittle carbide with this as well. The next section that I have is on flame sense and flame sensors. And flame sensors, you'd think, yeah, this is something pretty simple. It's just a metal rod that goes in front of the flame, and it senses that there's flame there. There's no relays, there's no moving parts. It's just a simple rod. Well, the time that I want to spend with this tonight is explaining that simple rod of how it works, what's going on with it, because the flame sensor is the industry standard for a safety circuit on gas-fired furnaces today. This is the way that the furnace knows that there is a flame. It proves that the gas is ignited. And without this safety, and if there was gas that came on and did not ignite, then you could have a lot of gas released in the furnace, raw gas, and potential for an explosion. And so this is a very crucial, important part of furnace operation, of sensing that that flame is there. So first of all, I want to dive into a little bit of science of how this works, understanding gas properties, and the first part of the slide deals with during the actual burning process. And to get a flame, or to get heat, to get a fire, with the fire you have fuel, you have oxygen, and you have a spark. And the fuel and oxygen are typically 3 parts. They're carbon, hydrogen, and oxygen atoms, and they are pushed into this burner, ignited, and then these atoms are separated. They come apart, and during this process of these atoms splitting, then you have the byproducts of the carbon dioxide, the fuel, the spent fuel or atoms going up out of the flue. And during this process is termed flame ionization. And during this ionization, where these atoms are burnt and they come together, the positive ions are freed from this process. And my slide here shows that as we have burning here, the negative molecules and the electrons, which are the negative particles, they continue on through the gas, whereas the positive electrons, they actually create what's called an ionic wind and are pulled back towards the burner. And these positive ions are an ion that simply, as it's traveling back towards the burner, has the potential to carry electricity with it. Now, it's only carrying half of this AC signal back to it. The other half is rectified, and therefore we call this a rectified signal. It's only carrying half of that sine wave back. It's carrying the sine back on the positive ions, and that's going back, and it's touching the burner ground. And so how this works, first of all, I failed to mention that this rod that we stick into the flame has AC voltage on it. It actually has current that's being pushed into that. Now, if you was to reach into a furnace and with it off, and there was voltage here, would you feel it? Would it shock you? The amount of amperage or current that's with this is very, very small. So the chances are you probably wouldn't even recognize or feel or know that there is 120 volts there at that. At the same time, it's like any other electricity. You want to respect it. You want to make sure that you're aware that the electric is there, and it's something that you're not intentionally reaching in and touching and getting a hold of. But that reason that a current is so small is it's carrying this micro amperage, this very low current signal, back through that wire back to the control board. And how it reads that, how it knows that there's resistance there, is the voltage that's on the rod is actually continuing through those positive ions to the burner ground, and it's completing the circuit. So an example of a circuit that you would know that you actually have resistance on is like an electric heat strip. If you have power 220 volts on an electric heat strip, or 110 and ground, because that electric is grounded, or that 220 is two different legs of power, it creates resistance on that electric heat strip and creates a red glow, creates heat from that, and that's your current that you're getting because of that resistance. Now, the glow on this isn't from the resistance of the voltage going through it. The glow's from the flame, the heat of the flame, but there is a very small amount of electric that is traveling from that probe back to the burner, creating that resistance, and that resistance is readable by the board. So the board's sending the electric, and then it's reading how much resistance or drag is on that electric back to the board, and that resistance, that rectified DC signal, is how the board knows that the burner is functioning and that the flame exists and is on. So this DC voltage grounding to the burner through the metal, to the burner metal through this positive ions, it's small enough that it can only be read in microamps. It's not enough. If you had a solid wire going to ground, then you could get amps. You could get a lot more resistance. A wire going to ground, you'd probably glow red and actually see that resistance. But because it's just the positive ions, it's a very small, minuscule amount going back. That's how a flame sense probe senses that electric, because it is carrying that voltage to ground. What happens if the flame sensor fails to function and operate? Well, the first option here is a film buildup. And this is something that most of you have probably seen if you've been out working on furnaces at all, and you pull that flame sensor out and it looks like it's got a little bit of a white coating on it. That white coating is a silicon oxide, and it's formed as a byproduct from the burning process. Now, typically there's not a lot of that that's formed on there, but the environment of where the furnace is and the fuel are two things that can have a bearing on how fast that builds up. An environment where there's other chemicals in the area where the furnace is, and those chemicals have any fumes that are in the part of this burning process. If there's any other atoms, any other product that's a part of that burning process, it could increase the amount of silicon oxide that's built up on that. The same way with the fuel. We don't see it as much with natural gas, but there's times within propane gas that if there's additives added that can increase this silicon carbide manufacturing process in the burning, you can have sometimes a propane furnace will increase that speed of which that silicon oxide is built up on that probe. It's a very simple product on the probe. It's something that's not hard to get off. It's not anything that takes a lot of effort. It's a really light film. It's almost like a light dust that you could just wipe your hand off and pick the dust up. That's how light and easy it is. However, because of its compound properties, it acts as an insulator and will insulate that signal going to ground and not allow the furnace or the control board to see that DC signal going back to it. Another thing that can happen with igniters, or excuse me, flame sensors, is surface degradation. And that is just simply the surface itself. If it's cleaned with coarse products, those products can etch it and cause it so that as additional times that there's flame around it, those etchings, those grooves have the ability to pull and adhere to a silicon oxide faster and build up faster. And so cleaning with something harsh will shorten the life of a flame sensor. It will have the potential for it to build up and fail seeing the flame faster. And then the final thing here that I have on this slide is the metal composition. The flame probe rods themselves, they've been made from variable metals. In the 80s, the rods were more brittle, and anybody that's been back in the industry from that era of time would have seen that these rods didn't take that heat and cool off as well as they do today, and they became brittle and had a tendency to break. In the 90s, as the composition of the metal was being tried and worked with, there were some of these flame sensors that the composition allowed them to grab a hold of and build that silicon oxide up faster. Today, White Rogers probes, they're made of what's called a canthal material. I'll explain that here in the next slide of what that is. And that material has been proven to be more stable, more reliable, durable, and can withstand heat better than the earlier versions that used to be made. So the composition of the flame sensors that we have, White Rogers has, there are OEM flame sensors that we're carrying that have the plug that will match up to 5 different manufacturers. And this year we are excited to launch a universal flame sensor as well that will allow us to bend and cut and make it fit any application. The materials of the flame sense that we currently are offering, the actual terminal is a steel nickel-plated terminal, and that nickel plating helps continue to keep solid contact on the wire that it's connected to so that it doesn't corrode and weaken that flame sense signal that's going back to the control board. The ceramic itself is aluminum ceramic. It's a very widely used, popular ceramic, advanced from the fact that it's extremely resistant to wear, very hard, and it makes an excellent insulator as well. And then the final part out here on the end is the canthal rod. Canthal is made of primarily iron, but it also has chromium and aluminum in it as well. And so it's a mixture of 3 metals that are blended together that have good conductive qualities that allow that electric to pass through it, as well as strength and as well as being able to withstand the heat and temperature. On each of the flame sensors, there is a CSA certified number, and also there's a date code so that you can actually tell when the sensor was manufactured and its age. This new premium universal sensor has a part number of 790-843A1. And the features of our new flame sensor is, as I've mentioned already, it can be bent and cut. I'll go into a little more details of how to do that here in the next slide. It's made so that you can bend it and cut it to replace over 120 different SKUs. It's really exciting from the fact that it is our most universal flame sensor, and from what I understand is the most universal flame sensor out there on the market, being able to cover so many different SKUs. The instructions list the cross references, and in the instructions you also see what the angle is. The instructions list an old flame sensor number, whether it needs to be cut, bent, or cut and bent, as well as the angle degree that is on the existing part number, how much of a degree that needs to be cut. These are CSA certified. They withstand 2200 degree Fahrenheit, and most of what is out there in the aftermarket flame sense realm right now goes to 1800 degrees. So we do have a higher temperature rating on the flame sensor itself, as well as the final bullet point here of the 3-year warranty, which again, the other universal sensors out there are currently at 1-year warranty on them. So hotter temperature, longer warranty, and covering more SKUs gives you a flame sensor that's a universal product to stock on a truck to be able to replace in a multitude of applications. So universal instructions within the FlameSense box itself. It comes within that box. There is a tube that can be slid over the FlameSense probe itself so that it can be bent, and that tube is protecting right where it's bent. And also it comes with this chart that shows 15 degree, 45, 73, and 90 degree bend. Those are the typical angles that most manufacturers are bending those FlameSense probes to, and so this will allow you to place the probe on a flat surface with this chart underneath it, and then bend to whatever that angle is. One comment about this, before you get your first one and try it, make sure that the attachment where you would put the screw in to attach the flame sensor to the burner area is in the exact same angle as the one that you're replacing before you make that bend. You don't want to just lay this down and make your bend on it and then find out that the hole with the screw is on the other side. So always, number one, match where that attachment hole is before you decide what your angle is and how you're going to bend it. The OEM brand and part number, along with this bending cutting requirements, as I mentioned already, are in the instructions with a universal flame sensor. One final thought on flame sensor care. Just a little bit more information here that I can share educational wise, is this very thin layer of silicon oxide that's formed on this flame sensor probe. That is what you're needing to remove. That's the insulator that's insulating that flame current from going to ground and the circuit board being able to see that. The best practices, back in the 80s, we were given instructions to use a dollar bill. No sandpaper, no harsh paper of any sort, just something as soft or as smooth as a dollar bill. You were just simply taking this film off. Steel wool that's very fine is another good practice, along with a piece of paper or an alcohol swab. I always like to carry a box of these alcohol pads on the truck so that when I got done cleaning a flame sensor, I wiped it off with that. There were no oils, there were no particles, contaminants, anything at all. It was absolutely perfectly clean, ready to go back in the furnace. Acceptable would be something like you might have heard called plumber's cloth. it's an aluminum oxide cloth. And that is something that you can use, as well as a putty knife. A putty knife is something, if there is a harder buildup that you are wanting to try to pull off of a flame sensor that's already been partially compromised, you can use a putty knife to get that off. Not recommended at all is silicon carbide sandpaper. Why? Well, silicon carbide sandpaper is that same sand that would be in silicon oxide. And so if you use silicon carbide sandpaper, you have the potential of having some of that debris left on there, and when you get flame on there, it's going to instantly start coating that silicon oxide on that flame sensor right away. The other thing not recommended is something like an SOS pad that has a detergent or another type of foreign material that's in it. And again, once you have flame on that detergent or material and it burns, it has the potential to have a byproduct of a compound that's going to be similar to this silicon oxide and coat that probe so that it doesn't have the ability to sense to ground. So SOS pads, definitely off the list of a product to use in cleaning. Failing to clean the flame sensor properly, you can have foreign material that's burnt on the probe, whether it's permanently burnt on there and you try to scrape it off, or just simply an immediate starting of an insulating of the probe as soon as it starts firing already. You can also scar and make rough surface grooves on the flame sense, which is going to allow that silicon oxide to build up faster. And you can also change this electrical signal going to the board by creating an environment that has that insulation build up faster, and you're not going to have as good of a signal for the board to read to sense that the flame is getting through there. So any questions at any point in time, feel free to type into Tyler here. He's chomping at the bits, wondering where all your questions are tonight. So I don't know if I'm covering it well enough, or if there's something out there. Don't hesitate to speak up. I'm happy for questions. I'm going to head on here to the next section of non-integrated furnace modules. And the first thing I want to do is explain what non-integrated is. And non-integrated is just simply a terminology here of a partial control, and it's not a complete control. Non-integrated simply means that there's one part and another part, and when you integrate them together, you can have a complete operation. And the example I have here in this slide is two different types of controls. The one here in the center of the top is a fan timer control, and that part would simply cover the operation, get the signal from the thermostat and send that signal onto an ignition type control, and the ignition control then would have all of the operation of the furnace firing and making sure that the burner is coming on. The fan timer module would simply operate and control the timing of when the blower motor would come on. So to be a fully integrated control, the control must cover all of the operations of the furnace. And we call them IFCs, or integrated furnace controls. And I'll use that throughout the presentation of what I call an IFC. And thanks for responding. Tyler has a question.
Going back to talking about the cleaning, Mike wants to know, is Scotch-Brite okay to use?
Scotch-Brite is a product that I did, thank you for the question. And Scotch-Brite is a product that was on that list. Scotch-Brite is a product that if you're using it, I would recommend that you use an alcohol wipe after it, because if you leave any foreign material of that Scotch-Brite on that rod, when it burns off, you have potential for it to build up and stay on the flame probe itself. So it's something that if you peruse the internet and searching for the perfect product, there's a lot of people that like Scotch-Brite. Acceptable, it will work, and will clean. Is it something that strong needed? Typically not necessarily, but the biggest thing is make sure that when you're done cleaning it with anything that my experience with Scotch-Brite is you get done and you have these little green particles that have came off of the pad, and those are the part that I would be concerned with when you put it back in. As long as those are gone, you're good to go.
Great, thanks. We actually have another question from Jason. He said, what would you recommend to use for cutting the universal sensor?
Great question. The universal sensor cutting is something that I believe we do outline within the instructions itself. So in case you forget this, but it's not anything that has to be complicated or a special tool. Side cutters will work fine. It doesn't have to be flat or smooth on the end. The surface area of the rod itself is what's sending that signal through the ions to ground. So to have a perfect smooth cut on the end, no issues. Anything that you can use to cut a 16-penny nail, you can cut this with. It's open for whatever you have available. Thanks for the questions. And I think we're ready to move on past this. Individually, these are all called modules. We don't call them controls because they don't control everything. I would refer to them most of the time as modules. Together, we would have a complete integrated furnace control. And I like this slide. I shared this with you last year for those of you who are return visitors here tonight. This gives us a history, and it's a lot of small writing. I'm sorry, it may not show up. You may be able to see it at home on your monitor, but this goes through, I dug around a little bit to try to get an idea of furnace control history. And it started way back in 1935 when there were these big old octopuses in the basements that were gravity forced air furnaces that had big pipes that went up to the first floor of a house. And the heat just simply came from the heat exchanger inside. Gravity floated, hot air rises, and it rose up into the house. There was no blower, nothing else along the line to get that heat into the house. In 1935, the idea came around, why don't we put a blower on the side of this octopus and turn that blower on and force that air around that heat exchanger and up through the house and get the heat up in the house faster. Well, in order to do so, a control needed to be made, and that control is made of bimetal, or two pieces of metal that simply sensed heat, and once they got to a certain temperature, they would bow or bend. And that bowing and bending allowed for a switch to be placed so that when it moved, it closed these contact points, and in closing the contact points, completed the circuit for the blower to come on. And that was the style of heating from 35 all the way up to 1968, when the first spark ignition system was patented and came on the market. And at that point in time, that is when I would say the non-integrated furnace controls started. It started with a bimetal furnace control or blower control, bimetal blower control, and a sparker that would ignite the gas and turn the furnace or start the burner. Then on in 1969, carborundum was silicon carbide came out with an igniter. So now we had the option of spark or a type of a hot surface ignition system. Then a big step in 1987 when we had federal regulations that said no more gas furnaces below 78% efficient. In other words, at least 78% of the heat produced by that gas needed to go in the house. 22% could go up the flue. And typically at that point, we never really saw very many 78% efficient furnaces. Those furnaces just simply started at what was called 80% efficient. And we had 80% and 90% soon after that. That was a change from this aspect. Once we got to that efficiency, to hit the 78 or 80% efficiency, we no longer could have a standing pilot burning 24/7. The furnaces with standing pilots ended their manufacturing in 1978. They all went to a direct spark or hot surface, some form of ignition that actually started that gas burner at the time or when the call for heat was initiated. And then jump another year to 1988, and in 1988 is when this fan timer or blower control was made, that instead of using a bimetal strip to determine how much heat was there, it was determined that a heat exchanger typically takes 60 seconds to warm up, or a minute and a half, or 2 minutes, and that a digital timer could be set to come on at that amount of time after the burner ignited, and there would no longer need to be this bimetal strip to determine when the fan was coming on and going off. A benefit to that was that bimetal strip over time would wear out and need to be replaced. With the fan timer, you never had this moving component that was going to wear out. It simply would time itself on, time itself off consistently every time. 2 years later, in 1990, we had the introduction of the fan timer and the ignition system come together. And so 1990 is what I call the beginning of IFCs, or integrated furnace controls. And that is currently what we're using even yet today. A couple more slides here. We went from this silicon carbide in 1969 to silicon nitride, which is what the hot rod igniters are, in 1997. And in 97, Train and Lennox led this movement of silicon nitride, and they led it with 80-volt igniters. Several years later, the 120-volt silicon nitride igniters came out, and with that, it was determined that you could have that full voltage. You didn't have to drop the voltage. Now, a word on 80 versus 120. I had a homeowner several years ago that had a technician come out a couple times a year and replace the igniter in their furnace. And I went out, got the model number off the furnace, figured out what the igniter was, and replaced the 80-volt igniter in the furnace. And it didn't last the year. I went back out for a no-heat call again and found that this 80-volt igniter had already failed. So I got the model number and serial number of the furnace, and I got the part number that was on the IFC, or the control module, the control board, excuse me. And I researched to see if that was the correct control for that furnace. And come to find out, at some point in time, that control had been replaced. Some technician had updated that control to a 120-volt igniter or ignition system on the board, but left an 80-volt igniter and had continued to put 80-volt igniters back into it. And so I share that at this point just simply, as you're out there looking to replace an igniter, don't just simply check against the model serial number of the furnace. Check against the control board itself. Make sure that the control board is putting out the voltage for the hot surface igniter that you're replacing. That's probably been 10 years or so ago, and chances of that happening are less today with most manufacturers as of 2006, going away from the 80 volt igniters, going away from spark. There is only one manufacturer out there that still predominantly uses spark. Everybody else at this point is using hot surface ignition. And as you see tonight, most of my topic and discussion is on hot surface ignition. That's predominantly what's out there, and that's predominantly what White Rogers sees as beneficial in offering in universal controls, with the exception of our next slide, this non-integrated module. We still have a lot of furnaces that use the direct spark module, and this module does work with those direct spark furnaces. Very popular module, the 50D 843, but these, again, they're modules. They're non-integrated. They're only half of the control system of the furnace. And the key to these is making sure that these are grounded to the furnace itself, that the furnace has a proper ground on it. Without a proper ground, that flame sense isn't going to be able to sense the flame through the module and connected to the burner ground itself. There are three options of these non-integrated modules that are universal. We have the proven pilot direct spark, as well as the hot surface 120 volt module. And so looking at these, we have here on these the fan timer plus any of these modules create that complete system. This fan timer is our final non-integrated component that I wanted to share tonight, the 50F06843. It is a product that allows you to time the blower on and off, and it can be connected with the proven pilot direct spark, hot surface, or a gas valve that has a built-in electronic control in it as well. The fan timer also has the ability to watch for a limit circuit, a pressure switch circuit, and blower failure, voltage fluctuations, depending on which one of these components it matches up with, and the furnace application on how many of those things do function. The fan timer is something that is fairly easy. We're halfway through, it looks like, so far. And so I got a little video here to share with you of how easy this is to install. And so I'm going to go ahead and let it play through. If you ever watch install videos, this right here, the Emerson White Rogers 50F06843, you can Google this for YouTube, and the video I'm sharing with you here tonight is readily available on YouTube as well, so that you can go anytime and watch this yourself. Also, a couple notes about it. I designed it not to be something that's a super long video that's going to take a long time to go through. I understand that if you're out in the field and you're wanting to watch something like this on install, you want to see something that's real quick, something that you can pause and start again, not something that you're going to sit there for a half an hour in front of the homeowner and watch a video of how it functions. So with that, I'll share this. This application is what we call with a second stage smart valve and the ST9160 application, and in the video you'll see the connection that makes this unique. So here we go. think I'm out. And there you have it. That's as easy as it is to install a 50F06843 electronic fan timer, something that there are quite a few furnaces out there that still use fan timers, and we're excited to be able to share that with you. There are three main types of controls that this replaces. The ST now I gotta. Yeah, the ST9160 is the one that we just showed you. That's that second generation, and it would take this smaller adapter going into the standard J1 adapter here that it's called, while the furnace itself would plug into the smaller one. The other two, the ST9141, would take one of these adapters, and the adapter itself has a tag on it that says ST9141. So if you're pulling out an old control, you see the model number on that control, you pull out the wiring harness that has the matching number on it, and you're good to go. The most popular replacement for this is the ST9120. The ST9120 requires no harnesses at all. So the majority of the time that you're going to use this universal board, you don't even have to worry about a harness. It doesn't even exist in the replacement of an ST9120. The ST9101 is another control out there. Not a lot of them out there, but we wanted to make sure that we covered all our bases, and that's what the other adapter harness is for. And on the harness itself, it will have ST9101 right on it, so you know when you pull that old board out that this adapter harness is what you need for that. Very simple. All of that is up front, easy to read within the instructions themselves. So 3 down, 2 to go here on our controls. The next is the integrated furnace control itself. And the function of this, it monitors and runs an inducer motor, pressure switch, the igniter, the gas valve, flame sensor, the limit safeties, and the blower motor. And most of the low voltage control, those operations are done through a plug pin connector. And there's two styles. This style right here is a 12-pin connector that we call a Molex plug connector. The other style is an 11-pin inline connector. And the 11-pin inline connector is a connector that is typically used with the Carrier controls. Carrier infamously decided that was what they wanted to use. And so those are the two main styles of plug connectors. And the 120 volt circuits that are on the board still go through individual spades. They don't connect through one of these large Molex plugs. That would be, the exception to that would be the inducer motor and the igniter sometimes go through a 2 or a 4-pin connector, but they would never go through a 9 or a 12-pin. The 9 and 12-pin Molex or the 11-pin inline are strictly for the low voltage. So you have all kinds of variations with this. The early IFCs, they had fewer pins. Some of them might have had 6, 9 before they got to the 12. The Carrier ones had the 11-pin inline. Here's a York with a 7-pin. There were different styles, different pins. The early models, this just simply shows limit 1, limit 2, gas 2. They were actual pins. or spades that wires would plug into individually. And they went away from the individual plug-ins to harnesses or plugs that had flat spots on one side of them so that they couldn't be reversed. They could only go in one way, and all the low voltage went together. So you have a whole bunch of different options here. And this is part of this unfamiliarity with universal and IFCs that I would say is the scariest thing that you're looking at right now in being able to say, I want to buy a universal furnace control and be able to use something like that. The universal kits, they include lots of adapters, and I think the one I want is back here behind me. And this one right here is the 50M 56U 843. And within this, there's a bag here, and in this bag is what I term the scary part. This is the part that's the unknown. But once you're familiar with this, and once you're comfortable with this, it's a walk in the park. And so let's look at this. Here we are, back to the greatest fears. I got all of these harnesses. How do I use them? Where do they go? Well, which one am I going to use for the furnace that I'm on? And there's different sizes. There's all different kinds of things that we're dealing with here in these different harnesses. This is that fear. This is the fear of the unknown of what I'm doing with this. Well, let's get rid of that fear. Within this same box, you'll find installation instructions. And within those installation instructions, you open them up, and 2 pages in, and you're going to find each one of these harnesses. And each one of these harnesses have letters on them. Here's E. I see this one has D. I'm trying to find one of these larger ones here that would have here is B, harness B. All I got to do is come over here, harness B. This is harness B. How do I know what I'm connecting to? Well, here in these instructions, as well as what you see on your screen. A is Goodman Amana brands and ICM. B is Nordyne, Ream-Rude brands. M is Carrier, ICP brands. Those are the main larger harnesses. You also have these smaller harnesses that have the smaller connectors. C is Goodman Amana, D, Ream-Rude. E, another Goodman Amana, going to a 2-pin furnace. And once you start realizing this is in the instructions, how to use each one of these, you'll know that this is the one I need, and the rest of these can go bye-bye. This is all you need. And that is simply the ease of installing our most popular, well-known IFC, the 50M56U 843. This one control will cover over 430 different SKUs. This one control can save you a lot of trips to the supply house. And that is the beauty of the idea behind Universal. Universal saving you time. It looks complicated. Once you buy one, try one out, and become familiar with it, you'll wonder why you hadn't done it a long time ago. It's something that's super easy to work with as well. While I'm on it, and I think I'll have a slide later to show, but the hot rod igniter does come with this control so that you can upgrade the control at the same time, or the igniter at the same time you upgrade the control. And I will have a little bit more on that a little bit later on in the presentation. So that's as simple as you can get for a universal furnace control. It's clearly marked in the installation instructions. There's several harnesses but the manufacturer of what brand is right on the front of the furnace is going to help you out. How do I know if this is one of the 430 that this works on is the one I'm working on? And that's the last part of the presentation, where I'll show you how easy it is to cross-reference over your furnace that you're working on with the universal control itself. Let's go a little bit more into the universal, the integrated furnace control selection. And these are the questions you have when you're replacing. What's your ignition source? Is it direct spark, hot surface, or is it a proven pilot, intermittent pilot furnace? Is it single stage or two stage? The other control that we have up here is another great universal control, the 21V 51U843, and the V in the middle kind of gives away the blower. It is a variable speed, or an ECM blower that this works on. It also has two stages, but it is as well a universal control. Is it PSC, which is what the control is that we showed you here a minute ago? This 50M 56U843 is a single stage PSC control. We have another control identical to this, actually with some additional benefits and features that I'll share, that goes with the X13 or the ECMX furnace. And then we have the universal that does the ECMV, or the variable speed. The simplicity and ease of these, once you've tried them, makes it difficult to go back. And I have a question.
Yeah, real quick from Stefan. He asked, is the part number on that box just for the board itself, or is it for the entire kit?
The part number?
Yeah, so the 50A 55843.
50.
He has a 50A, but
the 50M56U843, it is the kit number.
Kit number.
Yeah,
We don't sell just the board.
yeah, the 50M56U, this right here. Yeah, that's correct. It is a kit number. It comes with the igniter and all the harnesses. The 50A, we haven't touched that. I think we do have a universal 50A that I'll catch here in this next slide. If that is a question, we do have a 50A 55 and a 50A 56. They're both for the two-speed PSC blowers, and those are boards only. And those, the difference between those, you'll see in this second column here. One's for the 120 volt ignition system. The other is the earlier 80 volt systems, and both of those you can see from that. The 80 volt wasn't made as long. They have 35 plus cross references versus the 120 volt, which is the 130 cross references. The two that I was mentioning here prior to the question, thanks for the question, by the way, is the 50M 56U843, and then the 50X57, which is the X13 version.
Before we keep on going, I do have a quick question for Bruce. Yes, can I change out the PSC with a variable when changing the controls?
The control itself, good question, Bruce. The control itself is going to dictate what type of blower hooks up to it. If you're looking at upgrading from like a PSC to a X13, or I believe there are some motors out there that allow you to convert from the PSC to a more efficient blower. Those blowers themselves are going to have the wiring that's going to hook up to the PSC style. More than likely, you're not going to have a blower that hooks up to an ECM X or an X13. If you're versed enough with wiring, this is something that from our standpoint, I can't stand here and recommend. But the ECMX or the X13 motor, I've always likened it in a way to an air conditioner. An air conditioner has the line voltage going in through a contactor and going to the compressor, and then it has low voltage going to this contactor that closes the contactor to allow that line voltage to turn the compressor motor on. And an ECMX or an X13 motor is basically the same. You have line voltage going into that motor. Now that motor does have a module that's going to convert that line voltage to three-phase, which can kind of be a separate discussion, but that is voltage going in, and then you have low voltage, which are different wire taps that are 24 volts, just like the 24 volts going to a contactor. There's a common 24 volt, and then there's 3 or 4 different 24 volt speeds that determine which blower speed you have. And so if you was to take our 50X57 and at the same time you upgrade the control board, upgrade the blower to an ECMX or an X13, providing you're comfortable with the wiring, that's completely up to you. As far as recommendation from us, we would recommend that you stick with the board that goes as a cross-reference to the furnace and that type of blower, unless you're using a blower that's taking that voltage internally and converting it over to your higher efficient motor itself. Hopefully that answers your question there. It's a matter of preference. Is it doable? Yeah, but you want to make sure that you are matching up the control board with the motor itself. So these are your single stage controls. Back to the 50M56U on this. This here as well, right on the side of the box, has cross references on it so that you can see on the box if your board crosses over to it. And also you'll notice that some of these have orange over the cross reference numbers, and that orange indicates that that model is an 80 volt model. And so anytime you was to take the 50M56U and replace it with a board that the old number is in orange, that would mean that the igniter needs to be replaced at the same time, because the existing igniter, the ones in orange, have 80 volt igniters. That is why we include the hot rod igniter with the 50M56U, is because there are applications that igniter must be changed out so that it's 120 volts and it matches the 120 volt universal control. Otherwise, if it's not orange, that means the existing board is 120 volt on the igniter, and if it's a good silicon nitride igniter in there already, you may want to save the hot rod for a different sale and make a couple extra bucks on it, or you can help the homeowner out ensuring that they got a new 5-year warranty part and replace it all at the same time. The other universal, that's the companion to this, is the 50X57. And this is actually the industry's first universal solution for that X13. And one of the unique things that comes with the 50X57-843 is, in the slide here, it shows both the 12-pin Molex plug as well as the 11-pin inline carrier plug. And by doing that, we eliminated a lot of harnesses that would have to adapt the carrier board to the Molex, or carrier furnace to the Molex plug, by offering both pins and places to plug in. That's eliminating all of those harnesses that would, if we used one or the other, cross over with each other. So a great feature, as well as the inducer and igniter. We have both options of having the hot of the inducer and the igniter, which is the 2-pin, and then the neutral would go on the neutral spades, or you have the 4-pin, which has both the hot and neutral of both the igniter and the inducer all together. you have either option depending on which furnace you have. This will allow you to plug in to either one, thereby eliminating a harness that's taking you from one to the other. A lot of other features here that are parallel and identical to the 50M56. This is a great product. If I was to recommend 2 universal control boards for truck stock, it would be the 50M56U and the 50X57. Both of them are 843 or our number for universal controls. Those would cover the vast majority of PSC as well as the ECMX motors. Also, a note here on this slide, this ECMX board, the 50X57, it doesn't come with that hot rod igniter. And the reason being is as you look at the cross references that it crosses over, the boards that it's replacing are boards that are already 120 volt igniters. So you're not needing to replace that igniter in this application. It's already 120 volts. And we was able to lower the cost on the kit by not having that extra component in there with it, because your existing one would function fine as it is. The final universals are the 2-stage. There are 2 of them, the 50M51U and the 21V51U. One 2-stage is a 3-speed PSC blower. The other is an ECMV or a variable speed blower. Both of these, again, are hot surface ignition, 120 volts. And they both would come with a hot rod igniter. And they can be used with both 120 volt or 80 volt igniter applications. You simply have to upgrade the igniter with the one provided should you be pulling out an 80 volt application that had previously been in there. And that gets us here. We're wrapping up faster than what I wanted, but everybody's nodding their heads saying this is great. So, hey, we'll keep on going here. Gas valves. And this is probably one of the shorter ones I have here. My big key point that I wanted to share here tonight is just simply when you're looking at gas valve capacity, you can look at the furnace nameplate and it'll tell you, is it a 50,000 BTU or 75 or 100, 125,000 BTU. And the rule of thumb is for each burner, that burner output is around 25,000 BTUs. So my example here, the 3-burner furnace, the input is 75,000 BTUs input. And so if you're looking at an old piece of equipment or a piece that the nameplate can't be read anymore, and you say, well, what's my capacity? How do I know what my capacity is? Because if I want to put a universal gas valve in here, how do I know if it's big enough, it has the capacity to work with this furnace? And you can determine that capacity just by looking at the burners. The amount of burners will tell you very close to your capacity. Now there's instances a 3-burner may be called a 65 or an 85,000 BTU, but it's going to be fairly close. And by and large, most of your residential furnaces, you can get into the 5 and 6 burners, getting you to 125, 150,000 BTUs. The 150,000, the 24-inch wider cabinets, the old furnaces are the ones. They're going to have plenty of room for a larger gas valve anyway, so it's typically not an issue. But those are going to be the ones that you would be concerned with capacity-wise for most of our universal gas valves that we have to offer. When you're looking at the criteria of how do you determine, will a universal one work? Well, what's the ignition source? And again, direct spark, hot surface, standing pilot, intermittent, or proven pilot. And then what's the furnace rating? Well, hopefully you can find that rating. And has it been converted over to propane? And that's one of the things you always want to check, whether or not there is a propane kit in it or not. And then I have a valve here I'm starting to grab already, and I will show it to you here in a minute. The opening curve is the final characteristic. And there are some gas valves that as soon as they're energized, you got the full amount of gas coming out immediately. Others, you may have a little bit of delay. Others are very slow, and the gas slowly builds up to pressure.
We have a question from Kevin. The question is, on the IFCs, how elaborate are the diagnostic codes versus what the OEM boards would have?
Great question, Kevin. The diagnostic boards on all of our IFCs, and we'll switch back to that real quick. I didn't touch on those, but on all of our universal integrated furnace controls, the diagnostics are either equal, greater, or much greater than the OEM. There are OEM boards that have no diagnostic features at all. Our universal boards do come with two things that you can read from the LED lights. And I'm going to pull this one out to try to show it to you here on the camera if I can. And that is right here on the front of the board itself. There is the key of exactly what all the status lights do mean. The LED is a tricolor LED. It's we call it red, amber, and green. The amber and red are somewhat close to being able to determine its color, but there's more of an amber. The red codes are codes that give you faults. The amber and the green codes are typically codes that will give you the status, such as standby or the fan on. And the amber ones, I believe one of the amber ones is when the heat comes on. Also here in the bottom corner of the control board is where that LED is located. It's a fairly nice size bulb that comes up off of the control board and is very easy to be seen and read. And so your list back up here, your universal controls compared to what the OEM may have half of this typically compared to what we have. We definitely cover more of diagnostics of areas to point to you to show you exactly what to look for when you're out with those codes. So thank you for the question. One more thing, I keep having Tyler switch cameras on me back and forth. Sorry, Tyler. That is here towards the top of the board, something that I really want to point out. Universal, since we're speaking about things we have that your OEMs aren't, this is definitely a plus. This right in here, there are two little pins, and those pins are taking the reading of the flame sense. Now, if you're trying to figure out if you have low flame sense or if the board's not able to sense the flame, rather than pull the wire off and have to have a meter that reads DC microamps, these pins read just simply DC voltage, and most meters will allow you to read this DC voltage. Well, if you're reading DC voltage and you're trying to figure out the flame current, how do you convert that? Well, in case you forget, right here on the board itself, it tells you that you have a conversion ratio of 1:1. So 1 volt DC on your meter equals 1 microamp. And typically, your microamp reading on your flame sense is going to be somewhere between 2 and 5 microamps is a good reading. Our boards will sense a weak flame sense somewhere typically around 0.5 or half of a microamp. That would be 0.5 or half of a DC volt with your meter on these two pins right here on the board. Our universal controls, all of our IFCs here that do both the ignition and the blower, they either have these pins that come up off the board, or they have pads, little flat spots on the board itself to put your meter on, and you can test your flame sense without pulling your wire off. And one final benefit of that is if it's the spade connector or the wire that's giving that weak signal and you pull it off to do your test, you may not see it. By testing it right here on the board, you have not touched that flame sense circuit, and you're actually reading exactly what the board is seeing and able to do it without having to pull a wire off. So another great benefit and feature of the universal furnace controls, as well as those extra diagnostic codes. Thank you, Kevin, for the question. Great question. And back to gas valves. Here we go again. Final part of gas valves. We talked about fast opening, slow opening, single stage or two stage. And our universal gas valve options.
We did have another question from Stephen. He asked if the board was protected by a fuse.
Good question, Stephen. Again, and I don't know if I need to pull this out or not, but on all of the control boards, there are 3 amp fuses. I believe a few of them that would have a larger capacity. I don't know if you can see that or not. Let me go ahead and pull it out real quick. It's kind of hard to see. Do have a 5 amp fuse, but most of them, I should say, actually, here we got the one with the 5. This one has a 5 amp fuse. What I was going to say is all of our boards are fused. So yes, to your question, there are fuses on all of the boards protecting that low voltage circuit. Thanks for the questions. They are all excellent questions of things to look for in the universal realm. Any more questions? Very good. Thanks. Appreciate the interaction tonight. Good questions, and thanks for asking. If you have any more of any of those earlier products, it's not too late, even though I'm trying to talk about gas valves. I'm glad to go back and talk about any of those things at any point in time here. And in the meantime, gas valves. Universal gas valves, and the difference that you'll find in our model numbers, 36C, 36G, H, and J. This third digit or letter within the model number tells a good bit of the story of the differences. The 36C, there's only one of those on here. That's one that is slowly making its way to retirement. Maybe fortunately, maybe not fortunately. The 36C03 is a valve that we've had around for a long time, and that is a standing pilot valve. That is why I said we're heading towards retirement with that, is because we don't have a lot of standing pilot furnaces out there. You'll also notice that it has a 280,000 BTU capacity, so it can be used on furnaces a lot larger than what we even see within the residential HVAC industry. It is a single stage. The next two gas valves, the 36G, 32500 and 33500, are two valves that I'm going to highlight here in our next slide. Those are new this year. We just introduced those for quite a while. We have not had a gas valve that gives proven pilot ability, as well as being able to be small enough to fit into the application. The 36J has been kind of a standard for us, and that's what we have here tonight with us. And this 36J is the 24214 it is the slow open version that we have here. Why slow open versus fast opening? Well, those really are determined by the furnace manufacturer and how they design the burners. And typically, we're seeing a standard or a fast open gas valve be more predominant today, simply from the fact that the old furnaces that took the slow opening valve were furnaces that had what we called ribbon burners in them. And they were burners that the gas went in the front, and they went all the way down to the back of the heat exchanger. And when the gas flew in the front of the burner, it came up through the burner. If any of you are familiar with a gas grill, how that gas comes out around the edge or through holes all the way through it, that is the style that furnaces, all furnaces used to be back before 78 when they had 1987 when they had the standing pilots. All of those burners went all the way back into the furnace. If gas came in those too fast, gas could be coming up the back before the front actually had ignited, and by the time the ignition traveled to the back, you had an explosion, and sometimes it used enough oxygen at the back that it'd blow the whole thing out, sometimes even the pilot. So a slow opening valve was required so that as that gas came in, it would ignite all the way back through the whole burner. Similar to, again, the gas barbecue, where you turn it on and you actually see that ribbon or that fuel slowly go around it. It's not forcing a whole bunch of gas out there instantly going through this. It's going through at a slower pace. So that's the difference between fast and slow. Slow opening valves are still made. They're still out there. The 36J series are the series that I discussed at the beginning of the presentation, where there's 6 valves that cover the majority of the applications. I believe 80% of the applications that are out there right now can be covered by those. We now have the 36G that can take and be utilized in place of some of those simply from this fact right here. 4 inches from pipe to pipe. A nice close application, so that this is a more compact valve that can fit in a lot of different places, and it's also very diverse. The 36G can be worked with the intermittent proven pilot, hot surface ignition, or spark ignition, any of them. Well, if you have a pilot on here, you can see on the picture you got a pilot tube. What happens if you're using a hot surface ignition? You don't have a pilot on that. Well, within the kit, and I'm sorry it showed here in the picture, I need to add that to my picture, is a plug that goes in that, so you don't need to be able to push gas out the pilot tube. It's permanently plugged. It's not used. The same way with the top of the valve. You have the common, you have the main valve, and you have the pilot valve. Well, if you're using hot surface ignition or direct spark, you don't need to wire that pilot terminal. You're just simply common and the main valve, and when the main valve opens up, you're operating. So this valve is universal in covering all of those different options. And here by the last item, 140,000 BTU capacity natural gas. Again, this valve on your truck is going to stock what you need. You can have a fast open and a slow open in this that's going to cover from the 2-burner or 50,000 BTU furnace all the way to the 125,000 BTU, the 5-burner furnace. And a lot of our furnaces are going to be somewhere in the middle of that this valve will work in the majority of applications that way. Going back to this, the J series was the same thing. They were all 140,000 BTUs. So anywhere that the J series valve would have worked, with the exception of the two-stage. This valve, not this valve, the 36G valve that we're talking about tonight, will fit in its place. And we are on the home stretch. Thanks for bearing with me tonight. Enjoy having each one of you along for the ride, and let's talk about, we got all these universal products. How do we know? How do we know it's going to fit the unit that we're on right now? We got two options out here. One option is right on our phone, right out at the job site. The other is on the White Rogers website. If you're back at the office and you got a technician calling saying, hey, what do I need for this? This is the part number I have. You can look it up on the White Rogers website while you're there at the same time. For the mobile app, you can find it in the Play Store, whether you're Apple or Android, or if you got your phone with you right now and you switch it to the camera mode, you can go right up to your screen here while I'm talking and hold your camera up to this QR code, and it'll take you right to your app store, and you can download it while we're talking. This app right here gets you all the cross references, all of the information to be able to determine, will this universal work for me? And this universal, or this app, does a lot more than just simply the universal parts. There's more benefits and features that you can find within this app. And let's go on to how to search by product number. And what you would simply do is go through and ask the app, you want to search by your product number, and you can start typing in the product number. And as you type in, there's going to be a scrollable product list that gives you options for that. And this cross-reference number, I'm not talking about putting in a White Rogers part here to figure out if this crosses over. I'm talking about whatever product that you have out there that you're wanting to cross over. Whatever other brand that's in there, you can start typing that part number in, and it will be bringing, as you complete that part number, you'll see this list shrink to the available universal products that you have. And then when you click on that or tap that, it will give you the White Rogers replacement that will allow you to see exactly what you're looking at, that it does cross over. And if you happen to have one that crosses over to 430 plus different part numbers, this is going to be your puppy for your IFC. And then the website, if you just simply go to www.whiterogers.com, there is a spot from the home page. You can hover over tools and resources, and in there it's going to say White Rogers cross-reference product information. You click on that, and there you can enter your part number just like you would on your app, and that's going to be able to show you exactly what you need for the universal replacement. You can also find all of the catalogs on this site. You can also get spec sheets to know all of the specific details of all of those parts right here on this site. Most of that information you can also get on the White Rogers app as additional things you can pull from the app as well. So a lot of information here on universal parts, and I really appreciate you sticking with me tonight. Thank you for choosing us as a source for your universal products.